Ready.
Okay, so we're going to show you now after you have your sample in a spot here, and let's say our sample is in spot 1, okay? We have the sample in spot 1, and we're going to show you what we do here to run the data first, run the sample, collect the data, and then analyze that data afterwards, okay? So here's the software. The software, we have what we call Excalibur here, this Excalibur software. We have a shortcut to it right here. We also have a shortcut to it here in the start menu, right? You can get through it through all programs. Where's Excalibur? Excalibur, and then Excalibur here. All right. So a couple of 3 different ways to get to it there, and it will open up this window here. Okay. On this first icon here, you have 3 different options that we use the most. Actually, it's just instrument setup and sequence setup. Instrument setup and sequence setup. Okay. And in instrument setup, you don't have to mess with this, but this is where you set up your instrument and its parameters. Hopefully you won't have to mess with that. The sequence setup here, it's where you just essentially tell you write in here all the different components or all the different parameters that are necessary for the instrument sample to be run. You want to have a file name here. Usually this file name has something to do with your sample. Hopefully, oh, I didn't tell you that when you take your sample, you want to label it well, so that you can remember what the value is by writing on the side of the sample some 4 or 5 digit code that has something to do with your sample. Usually a few letters that remind you of the name or something like that, right? So that would be your file name here. Instrument method, this is always going to be the instrument method that you want to start with at least. If we get into changing the method, that would be something else. But so you can always get to it by double clicking this and browsing your way to this method here, okay? Position, this is where you put what number you have it on. So if we put it in sample 1 here, we would put 1, all right? The water sample that we have in there is at 100. Injection volume, 4 microliters is generally what you want to do, your injection volume, okay? So after you have that done, you highlight the row that you want to run, and if you want to run multiple rows, you highlight those rows. So if you put in 4 different samples and you want to run those 4 samples, you would highlight all 4 of those samples. You have to make sure all of them had the right position according to where they were, right? And then you would click on this one right here if you were running 1 sample. If you were running multiple samples and you had multiple samples, then you would this one would be grayed out, and you click onto the one to the right of it, okay? And when you click on that, it's going to open up this sort of a thing here, and it's essentially everything, and you're just going to say okay at this point, okay? So, and then the sample would begin to run. Over here in status, on this side of the page, you can click and see how the connections are going. Right now these need to say ready to download. Like this one says ready to download, these ones need to say ready to download. When there's power outages or flickering, or sometimes just over time, they lose connection, and so you have to kind of restart them, all right? And if you have any questions with that, you can just come see me. Generally, that can be accomplished by turning off these 3 here, and then turning them on. And then sometimes you have to close this software right here, this Excalibur software. Sometimes you have to close that Excalibur software, and then after these kind of make a clicking noise because they're restarting. There you have a little bit of clicking noise. Just wait for maybe about 3 minutes, and then after that time, you can reopen Excalibur here and then see if they become ready to download, right? And after these things warm up, these often, if not that time, sometimes it gets stuck in a little bit of a rut and you have to restart the computer and do this same thing. But eventually these will be ready to download, okay? So if we go to sequence setup, we can also, if we open it up just the first time and there's nothing here, we can open up the most recent sequence data. All right, and that'll bring that all up. Okay? So after you do that, ready to start, it's going to say okay. You're gonna say okay, and then it's gonna start the sample. Now the method takes about 2 hours to run one sample, and when it's done, you're going to have some data, all right? And the data is going to go to this data folder right here, all right? This data folder, and the file name is going to be something that has to do with your name that you gave it here, right? If it's the first time you've run that sample, it's going to be the file name is going to be exactly the same as that one, all right? If it's the second time, then it's going to say something like that file name with a number behind it, like this. Like this is test. These are 3 different times we ran tests, and those are the long file name numbers that it attaches to them. Does that make sense? Okay, so you're going to have your data file. All right? The easiest way usually to find the data file is to go to this data folder and click on date modified, and the soonest one here is going to come to the top, and that's going to be the one that you just did, right? Does that make sense? You can also search by name if you can't find it that way, but generally the most recent one is going to be this one here, okay? Here's one that somebody ran. It looks like it's a reasonable size. A reasonable size should usually be about 150 megabytes, 100 megabytes, maybe 75 megabytes, all right? So this is the data file here, okay? So now we've collected the data, and this is the data file, and now we need to start our analysis of the data, okay? So to analyze the data, essentially what we're trying to do is we're trying to extract all of the proteins that have been identified by the instrument, okay? So to do this, we double click, or no, sorry. We have to go to a different software. The first one we go to is the mass matrix conversion, all right? Because we want to convert this data file. Oh, it's already open. Here it is right here. We want to convert this file to something that we can, something else that we can actually process the data. We don't have software. The software to process this data directly comes through this company, and it costs like $10,000 or something, and it's not not worth the money for how much we actually do this data analysis. And it's also a good lesson to help you learn the different steps involved in this. So this was an online free conversion software, and you just drag the file that you want to convert into here, and then you say run, okay? You say run, and then it starts converting it into what we call MZXML, and then I can't remember the name of it, an MGF. It's going to make an MZXML and an MGF of your data. Now this data was called R30, R30.raw. This is the raw data. So it's converting the R30 to MZXML. Now it's done doing that, and now it's converting the R30 MZXML to an R30 MGF file. And it's the R30 MGF file that we really want. And now it's outputting the MGF file, okay? And after it's done outputting that MGF file, then we'll open it or we'll take a look at it with another piece of software. This MGF file and the MSXML file, or MZXML file, will be put in the same data file where the M30 initial raw file was, okay? So it's done now. It says 100% finished. You say okay, so you can click on okay here, and then you can go in here, and then we can go to date modified, and we go to the top again, and oops, this is the date modified. Here you have the 2 new files that you made, the R30 MZXML and the R30 MGF. So these are data files that, this specific one here, the MGF, which stands for mascot generic file, is the file that we can analyze, okay? Now, online here, there's a site called Matrix Science. Okay. Let's see. Where are is this the favorites button? Where's the favorites button?
Is it up in the bookmarks?
I'll talk to the ones who have been working on this and see why they don't have this up there. I think maybe it's because, no, I don't know. I don't know. I'll ask them why they took it down. Maybe it was getting too plus, or, you know, they've used it a lot, so I don't want to mess up the computer for them. But I'll ask them why they have decided that they don't want that there. Maybe I'll put it up there. But anyway, this matrix software, and it's at www.matrix.com. You can type that in. Or actually, you can type in this whole search engine if you want to get right to this search engine. It's called a Mascot MS Ion Search. Now they have lots of different searches that they provide, so you got to make sure you're on the MS Ion Search and that it looks just like this. Okay? So when you get here, there's a few things, few parameters you need to change. This is one of them, the peptide charge. You need, oh, sorry, I forgot a step. There's one other step. Before we can put it in here, there's one other step. The other step is this. It's actually in this data folder here. I'm going to go to type. It's this MGF splitter. MGF splitter, okay? I double click on the MGF splitter. So, going back to this matrix thing. This is an online MS Ion search that will be able to identify which proteins those peptides came from and then tell you the list of the proteins that were supposedly in that saliva sample. But it can only do, for the free version, it can only do 1,200 at a time. So what we need to do is we need to take our raw file, which generally will have about 1,000, and we need to split it up into fragments that are about 1,200 large, so that we can put it in here and use the free software. Otherwise, again, this one costs about $7,000 a year to have access to their upgraded version. All right? So it's a little more work for us, but it's, again, good for the students to learn. And the way we split up that MGF file that we created is by using this one here. So you double click on this and it opens it up. And essentially what we're going to find now is our M30, is that what it was? Or R30?
It was R30.
I'll go to view the details and I'll go to date modified and it'll bring it to the top, yeah, R30 MGF. So I double click on this and it says you've chosen this, open this file. Is that the one you want? You say yes. And then you say how many blocks do you want in this file? And usually I put in 1,100. You can put in up to 1,200. And then you say okay. And then it's going to open or make a new folder in this data file, same data file. So we say open, we say okay, and then we wait for a few moments, and we can see here it's now creating this folder R30, and it's putting these files into R30. Okay? And so these are all MGF cuts, and when it's done, we say okay. And now we have cuts 1, 2, 3, 4, 5, 6, and 7, and 8. All right? And so now we can go to this Mascot MS Ion Search page. We change peptides to 1, 2, and 3. That's one thing we want to do. And we also want to make sure the instrument is ESI trap. Everything else is okay with our default, but those two things need to be adjusted. Those don't come as the default. Then we come in here to browse, and on this page you can look at the different parameters and see the different things. This is the database that they're going to search. Yeah, and there's some other isotopic information, precision information. So we're going to browse here to our file, and that was R30, and we're going to start with the first cut. All right, and then you would start with the first cut and stay start search. All right. While that one's searching, you can go over here and do another one. We're going to go up and go to R30 and start search. We'll do our second one. All right, and start search. And usually you can search 3, sometimes 4 at a time, sometimes only 2. It depends on how their server is working on that side. But it takes a little bit of time. But here we'll see some. You're still recording, right? You're checking that everyone's phone? All right. So here we'll see Mascot results in just a minute. It's going to give us a list of proteins, all right? A list of proteins whose peptide fragments were found. Associated with these proteins are generally going to be a score of some kind. Now sometimes the scores are high, sometimes they're low. The higher the score, the more fragments it found from that specific protein. Kind of hard for us when we fragment the data to know the reliability of the scores. But here it found 13 proteins in our first sample, okay, in our first cut. And these are the names of the protein that it found, and these are the scores, all right. Anything under 30 really anything under 40, sorry, is generally not something that you would trust. But if it says human and it's under 40, you still might want to keep it because there might be a different reason why you don't get as strong a score, all right? So generally what we do is anything that's human we keep because, and if it's under 40 and it says human, we keep it, but we kind of remember that, oh yeah, that was under 40, it might not be legitimate. But otherwise, these are the names of the proteins here. So you have LAC2 human, you can right click and copy, and you can paste that to a, let's see, I don't know if I ever got Office on this thing. We got to get Office on here. I don't know how they're, what they're doing for data collection at this point. But these are the names of the proteins that you'll be looking at, right? So you got really 1, 2, 3, 4, 5 human proteins. This mouse one, you know, is probably, I mean, it's weird that we would find something from a mouse, right? Can you think of why it might say mouse?
They have a similar protein?
That's right. It might be a similar protein. And to check that out, you can click on this arrow, and when you click on that arrow, it'll open up anything else below. And right here, it'll say different same sets that you have. And if there's a same set here, it'll have all the same sets listed. And if there's one that says human, then you can get it. This one didn't have a same set for human.
It did?
So
when you clicked on it, no?
Right here? Oh yeah, you're right. Sorry, there it is. There's the same set right there, and that's the human one. So that's why it came up with it. Does that make sense? So that would be one you'd want to include there as well.
Okay.
All right? So we're just doing a qualitative thing. We want to know what proteins are in people who do and don't have diabetes, right? So you'd want to collect all of these from one sample and say they don't have diabetes, and then next one they do have diabetes, and then start trying to see patterns at that point. And we can talk about further data analysis at that point. Does that make sense?
Yep.
So next, just again, to make sure you understand what's going on, we could go to the one that was second, right? The second same set. This one got 23, all right? So we got all these human ones we have to go through. Gorgo, that's gorilla. So the likelihood of there being a same set is really high, right? So you could go in here and look for, there it is, well, let's see, one same set for Gorgo. There's IGHA1 human, right? We can close that up. But otherwise, you're going to want to go through all of these here. Here's a lot. Here's one that's above 40, and it's not human. So we can look and see if there's a same set. There's no same set there, so, you know, that sort of thing is interesting. It's hard to say exactly what it means, but there's no same set, so that's not going to be our field of data. If you start seeing trends, though, like that, you don't want to let them escape you, right? I mean, we're not going to have you collect every single protein. We're just going to go for the human ones. But if you start seeing, hey, I see that this one is always in people who have diabetes, then it could be a protein that's not identified as human, but because it just hasn't been discovered yet, but is in our genome and could be useful for some reason. Does that make sense? So you don't want to let those things escape you. You know, I can't really teach that. You just have to kind of look for trends and be aware of what's going on. But yeah, okay? Does that make sense? So 11 out of 20, and then there's a third page here, obviously. Go and look for some data as well. Okay, so we've done 2 of the 8, right? If I remember right, there were 8 cuts here, right? So you want to go through all 8 and then put that all in one list, and this person had diabetes or whatever, and look at that sample. Does that make sense? And then after we get all those samples, and we will analyze the data further.
Okay.
Does that make sense?
Yes.
All right. Great.